All right, you guys, before I start, I just want you to have 3 colored pencils. So if you can pull these out of your Tinker box, that would be helpful. I'm going to use these 3 colors. I'm going to use my red, my purple, and my light blue. All right, so first up, I just want to go over area in 3 different ways. So I'm showing you 3 different ways to get to the same end result. That is the goal. So first method here, I'm first just going to ask myself, is this a right triangle? So is triangle BAT, is it right? How would I know? Well, I would know that if I have 2 sides that are perpendicular, that would create a right angle, and then this would be a right triangle. So I'm going to look at the slope right here of BA. I want to find its slope, and I want to see what this slope is right here, AT. AT slope. All right, so for BA, I should see that I'm going up 4 and right 8. And when I reduce that, that's a 1:2 ratio. So the slope here of BA is 1:2, 1/2. Okay, for AT, we're going down 8 and right 4. So -8/4, -2. So we should see that, yes, they are perpendicular, which means that this right here is a right angle because those slopes are opposite reciprocals. So let me just write that. So BA is perpendicular to AT. That's what's creating the right angle. The slopes are opposite reciprocals. Which means that our triangle is a right triangle. So if it's a right triangle, I just need to figure out what are my legs? What are the legs going to be? And the legs are these segments here, BA and AT. So when I know my legs of a right triangle, that's my base, that's my height. So I want to find what this measure is right here. And then what is this measure right here? I want my legs. Those are my base and my height values. So I want to find the measure of BA first. All right, so if I look at BA, I could use the distance formula and use these endpoints. That's fine. Or you can do the shortcut that I've been taking you on for quite a while now. So I'm going to visualize this right triangle, right? So I'm looking at this right triangle right here, and I'm trying to solve for its hypotenuse. So the vertical span here is 4, horizontal is 8. We solved that by doing the slope. So now I can do my big square root, 4 squared plus 8 squared. So 16 plus 64, which gets me 80. So I have the square root of 80, which I know is 16 times 5. And here's a beautiful pair of 4s. That 5 is going to stay behind. So BA is 4 root 5. Okay, I also need AT. So I'm going to write here, find AT. Find its measure. So here again, I'm going to use my right triangle trick to figure out what the length is of the hypotenuse of that right triangle. So here, if I sketch that out, looks like this. And that horizontal span is 4. Vertical is 8. Again, I knew that from doing my slope. So now I know that, oh, it's the same triangle, right? The same right triangle where I have legs that are 4 and 8. So this has to be 4 root 5 also. Let me add that to my picture right here. This is 4 root 5. This is 4 root 5. So now I want to find my area. So I can visualize my triangle as it is. So I can just redraw it kind of down below like this, where this is 4 root 5 and this is 4 root 5. Or I could rotate it. Sometimes it's more helpful to visualize it. Rotate it. And I can see, okay, well, my legs are still both 4 root 5. Okay, so similar ways of looking at the triangle. So here I'm looking at it as it is, and I've just rotated it, but it's the same triangle. Okay, so now I want the area. Area is 1/2 base times height, right? It's half of what it would look like as a rectangle. So I'm going to plug in my 4 root 5s for the base and the height. So half of 4 root 5 times 4 root 5. So that ends up being half of 4 times 4 times 5. So half of 4 is 2, times 4 we get 8, and then times 5 we're at 40. So we have 40 square units. All right, so we know the area of the triangle is 40 square units, but I'm trying to show you how can we approach this and solve for it several different ways. So my next method, let me slide it up. So my next method is looking at my triangle, and let's say that I tell you that BT, let's treat BT as the base, and let's make A the vertex. So BT, segment BT, is the base with vertex A. So here's my base and here's my vertex. So let me just shade my base in red. Okay, so what I need to do then is I need to figure out, well, where's my altitude? Because I need it to get to my height. So I'm going to draw in the altitude. Okay, which is the perpendicular segment connecting the base to the vertex. Okay, so I need to figure that out. And the length of the altitude, that is my height. So what I need to figure out then is what is the slope of my base? Because I know that the shortest distance from a line to a point is that perpendicular pathway. And it's that perpendicular pathway, right? That perpendicular pathway that will be my altitude. So I need to figure out what is BT's slope. So BT, right, that's my base. Let me just remind you, base. What is its slope? All right, so here we can see that we're going down 1, 2, 3, 4, and then going right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So down 4, right 12. Reduces to 1/3. All right, so this slope is -1/3, which means that the slope of a line or segment that is perpendicular has got to be the opposite reciprocal, +3. So if I build off of that, let me go to my point here, and let me use a slope of 3. So I'm going to go up 3, right 1. And I'm going to keep that pattern going down. So down 3, left 1. Down 3, left 1. Down 3, left 1. So I can see what my line would look like, right? This is that perpendicular line that would pass through this point and this line right here. Okay, but the portion of it that I'm really interested in is this portion between my base and my vertex. I've already established that this is a perpendicular pathway. So I have a right angle right here. So if I want this measure, I want here, that will be my height. So I've drawn in my altitude and its measure is my height. So now I need to find my base and my height. So find base first. So I'm picturing this right triangle right here where I'm solving for the hypotenuse. And we already know from the slope that we went down 4 and right 12. Okay, so now big square root, looking at 4 squared plus 12 squared. So 16 plus 144, square root of 160. Okay, that is 16 times 10, and a pair of 4s. So our base is 4 root 10. So 4 root 10 right there. Okay, I need to find my height. So find the height. So again, that's just the length of the altitude. Length of altitude. All right, so then I'm looking right here, right? That's what I'm trying to get. So if I picture this right triangle here, let me draw that in. So here I can see that the horizontal span is 2 and the vertical span is 6. So big square root, 2 squared plus 6 squared. So I have 4 and 36, which gets me 40. So square root of 40. Okay, I know that that's 4 times 10, and here's a pair of 2's. So 2 root 10. Let me add that to my picture as well. So right here is 2 root 10. So now again, I'm just going to visualize my triangle off to the side like this. I'm going to draw in that altitude right there and label that this is 4 root 10. And here is 2 root 10. So I know that my area is half the base times the height. So half of 4 root 10 times 2 root 10. Which again is like saying half of 4 times 2 times 10. So half of 4 is 2, times 2 is 4, times 10, and we are back to 40 square units. Okay, one last method for showing area. So here what I can do last is I can draw a box around my triangle. So really I'm creating a rectangle. So draw a box, a rectangle around the triangle. Okay, so draw a box, a rectangle around the triangle. So I'm just boxing it out. All right, so there is my rectangle, right? I've boxed out my triangle. And I'm trying to picture it as 3 separate right triangles, so I'm going to shade them in different colors. So I'll make this one red. I'll make this one purple. And I'll make the last one blue. Okay, so now what I want to visualize is I want to visualize my rectangle area first. So my rectangle looks like this right now. And let me add in what these measures are. So here is 8 and 4. Here is 4 and 8. Here is 4 and 12. So my rectangle is really a base of 12 and a height of 8. So I know that area is base times height. So I'm saying, well, what's 12 times 8? And we know that that rectangle is 96 square units. So now what I want to do is I want to remove those 4 right triangles. So I'm going to say subtract the area of the 3 right triangles. All right, so each right triangle, right, we're doing 1/2 base times height. So let me just write it out for all of them. And it really doesn't matter for a right triangle what we call the base and what we call the height. It just has to be the 2 legs. So for this one, I'll make it 4 and 8. So what is 1/2 of 4 times 8? Well, 16 square units. Okay, for this one, we also have 4 and 8, so we know it's going to be the same. I'm just going to show you the work. 16 square units. Okay, and then this one right here, I have the 4 and the 12. So 1/2 of 4 times 12. So 2 times 12 is 24 square units. So I want to take my rectangle, which was 96, and I want to remove these 3 triangles. So take away 16, take away the other 16, and take away a 24. So let's see what happens. What happens when I do that calculation? So I take a 96, take away 16, another 16, and a 24. And we are left with 40 square units. So really, this is just an exercise to show you that there are multiple ways to get to area, right? Area of a triangle, 1/2 the base times the height. If it's a right triangle, you can use the 2 legs, make that the base and the height. If it's not, we can pick any side, make it the base, and draw in its altitude to connect to a vertex, and then do 1/2 base times the height. Okay, we could also box it out, draw this rectangle around the triangle, and then remove these 3 right triangles. So many methods for getting to an area of 40 square units. Okay, lastly, I'm going to have you find the area of right triangle MAN 2 different ways. All right, so first thing that I want to note, I want to tell you right at the start, is that our answers should be pretty close. They don't have to be exact. They should be within a few tenths, and it would just be a small degree of measurement error. So I'm going to add that right here. So our answers should be within a few tenths. If you can get it closer, then great. Okay, so first I'm calling it a right triangle, and I'm saying that A is the right angle. So let me identify that. Angle A is the right angle. Okay, so then I could just visualize it as a right triangle. So right down here, I'm going to draw myself, let's see, I'll do it right up here. I'll make myself a little diagram of the triangle, so angle A. So I want to figure out what are my 2 legs, what are their measures going to be. So I'm going to measure it with my ruler. I'm going to use centimeters. So here, if I'm measuring M to A, okay, and I'm trying to get as precise as possible, okay, I would put that at 9.8 centimeters. Okay, and then I need over here, from A to N, trying to get as tight as possible, that looks like 7.4 centimeters to me. All right, so if I'm treating it like a right triangle, where this is 9.8 and this is 7.4, I can do area is half the base times the height. So half of 9.8 times 7.4. What is that going to get me? That's going to get me about 36.26 units squared. Okay, so now I want to do it a different way. So I want to imagine that my base is mn, and I want to get its altitude. So let me use a different color. I'm going to redraw my triangle right here. But I want here, I want to figure out what my altitude is. So I'm going to look for my base, and then I need to figure out the altitude, and its measure will be my height. So first I need to get, what is the measure of mn? So I take my ruler, okay, try to line it up as closely as possible. And I would say that that is 12.3 centimeters. Okay, so now how do I get my altitude? Well, I need to use my compass. So what I'm doing is I'm looking at this pathway here and this point right here. And I'm trying to figure out how do I get my perpendicular pathway that connects this line and this point. So what I need to do first is I need to open my compass to a width where it's going to actually slice through that straight pathway, the base, right down here. So here I have it right to that width. I'm going to make it a little bit wider because I want it to shoot through on both sides. So this width right here, this is a good width to have it set as. Okay, so now I'm going to draw an arc that slices through on both sides, just like that. So again, I had it open to this width, and I wanted to make sure that I could get it to slice through on both sides like that. So now what my construction is really doing, it's picturing that this is the segment right here, and I want to bisect this segment, create that perpendicular bisector. So that's really what the construction is doing. So now I want to put my pencil here. Okay, I could keep it open to this width, that's fine. Watch, I'm going to verify that it slices through where A is, good. And then I want to make an arc right below, like that. So I'm just keeping the same width. I don't have to alter it. I could make it go narrower, that would be fine. Okay, but I'm fine with this setting. Okay, so now I'm going to go over here, and I'm going to just verify that we're at A. Yep, great. And then down below, where does it slice through? Right there. Let me slide up so you can see it all. All right, so I see that I have these points of intersection here and here. So I'm going to take my straight edge, my ruler, and I want to connect from A to that point of intersection right there. All right, so in doing so, I've just constructed the altitude because now I know that this is a perpendicular pathway. That's a right angle. So I need to figure out, well, what is my height? What is the measure of that altitude? I want this measure right here. So let me go ahead and measure it. So using my ruler, right, approximately, I would say that that is 5.9. So 5.9 centimeters. So over here, my little mini diagram, this base is 12.3 and the height is 5.9 approximately. So here I'm going to do 1/2 base times height. So half of 12.3 times 5.9. And that's going to get me about 36.29 units squared. Okay, so here I'm within a few 100ths, right? I got pretty close, and the only reason that I'm off at all is just a slight bit of measurement error, but nothing big, no big deal. So here we're seeing that our areas are virtually the same, right? Our answers are within actually a few hundredths here, within 0.03 units. So we got pretty close. So again, just different ways to visualize area. All right, I'm going to go through one more example just so we understand the construction. In class, I will probably just do one example, but B is just so you have an extra opportunity to practice this skill. All right, so again, I'm looking at area two different ways. Let me sketch out my triangle, my right triangle. So here's that right angle. I need to know my two legs. So let's measure in centimeters. So right here, this is going to get me, let's say about 6.2. So 6.2 centimeters. Okay, over here, I'm going to measure it as well. And I'm going to get about 8.6 centimeters. So I have 6.2 and 8.6. So if I use my two legs, because it's a right triangle, area is 1/2 base times height. So half of 6.2 times 8.6. And when I multiply across, that's going to get me 26.66 square units. All right, and then I want to approach it a second way. Let me just redraw the diagram. So now I want to treat MN as my base, A here as my vertex here that's opposite, and I want to figure out my altitude. So I'm going to draw in my altitude. Its measure is the height. So first, let me just go ahead and measure MP or MN. MN, that is my base, and that looks like, let's say 10.6. So 10.6 centimeters. So right now I know that this span is 10.6. But I'm going to need my height. So I need to get my altitude. So here again, let me figure out a good setting for my compass. So here I'm at point A. Here I'm right at my base, so I'm going to overshoot just a little bit. I want it to be a little bit wider. So this feels like a good setting. Let me just hold it like that so you can see that feels like a good setting. So now I'm going to make sure my needle is on A, and I'm going to swing through like this. Okay, so here again I have these 2 points of intersection. So I'm picturing really a segment right here, and what I'm trying to do is construct a perpendicular bisector so I can get a perpendicular pathway just like so. So I can keep my compass at the same setting. I could also make it go a little narrower. That would be fine. So this time I'll make it go a little bit narrower just like so. Just to show you what happens. Okay, I just have to make sure that I'm more than halfway from this point to this point. So this looks good. So now I'll make an arc above and below. And then I'm going to switch over to this point of intersection right there and make the same arc above and below. Okay, when I draw in that perpendicular pathway, I can see that it's going to connect through point A as well. So there's my perpendicular pathway, right? But I'm interested in from A to where it meets the base because I know that is perpendicular. Okay, so I want to find the measure of my altitude, which is my height right here. I'm just going to highlight it in red. Okay, so now if I measure it in centimeters, let's see what we get. So from A to my base, that's 5. How nice, that came out clean. So 5 centimeters right there. So here again, I'm saying area is half the base times the height. So half of 10.6 times 5. So if we multiply across, we would get 26.5 units squared. So again, slight bit of measurement error, but we are pretty close. So area 2 different ways, slight bit of measurement error, but here we got 26.66 square units, and here we got 26.5. So I'm going to say that that is close enough. We are within a few tenths. All right, that's all I have for today. Have a good rest of your day.